Let's try the next example, which is 4 cubed raised to the second power. This time we have a power on top of another power. So when that happens, we are supposed to distribute the exponent to the other one. So that just means we get 4 to the third times 2. And when we multiply those two exponents, we get 4 to the sixth. So now we have to do 4 to the sixth, which is 4 times 4 times 4 times 4 times 4 times 4. When we multiply these, we can multiply 4 times 4, and then that times 4, and then that times 4, and so on and so forth. And when we do that, we should get 4,096. And that would be our answer evaluated. Next one, we're on 4/5 to the third power. 4/5 to the third power is telling us we have a quotient raised to a power. So we're going to take that exponent, basically distribute it to both the 4 and the 5. So we should be doing 4 cubed over 5 cubed. And that tells us we should do 4 times 4 is 4 over 5 times 5 times 5. So when we multiply those, multiplying 4 times 4 times 4 gives us 64. 5 times 5 times 5 gives us 125. And that is 4/5 raised to the third power evaluated. The last one of these examples here would be letter D, 7 to the 6th times 7 to the negative 8. When we multiply 7 to the 6th times 7 to the negative 8, we have the same base, so we keep it the same. And we just take the exponents and add them. So 6 plus negative 8 is going to be negative 2. And at this point, we cannot have a negative exponent. So we basically assume it's like over a negative 1. And we're taking the exponent that's negative and flipping it to the other side. So that gives us a 1 over 7 squared. And 7 squared is 49. So this answer would be 1 over 49. Next example. We have a couple of properties here. We're multiplying, and we have exponents on these that we should be adding. So what we're going to do is look for terms that have the same base. We have a 3 that's the same in both. We have an a that's the same base in both. And we have a b that's the same base in both. When we have the same base, all we do is add the exponents. So I have a 3 squared and a 3 with no exponent, so you assume it's to the first power. So we're just adding the exponents 2 plus 1, so that gives us 3 cubed. And then we have an a to the fourth and an a to the second. So when we add those exponents, we get a to the sixth. And we have a b to the seventh and a b to the negative first. When we add a 7 plus negative 1, we get a 6 as well. So we have just simplified, which is all it's telling us to do, simplify the expression. We have simplified with the same base and the exponents. I can evaluate the 3 cubed when it says simplify as well. So I could do 3 cubed, which is 3 times 3 times 3. That would give me 27. And then the a to the sixth, b to the sixth stay. So either one of these answers would work when it says simplify. The next one, this time we have exponents outside the parentheses. When you have exponents outside the parentheses, that's when you have to distribute it to everything in the parentheses. So I'm taking this 3 and I'm distributing it to each of those exponents. So that's going to give me 2 cubed. And when I take this a to the fourth and distribute a 3 to it, so it's 4 times 3, would give me a to the 12th. Same thing with the b to the 7th. You'd multiply the exponents. 7 times 3 is 21. And then over here I have a 3 squared and an a that you don't see an exponent, so you assume it's raised to the first. So at this point, I look for something that has the same base. So I see an a to the 12th and an a to the first. Other than that, I don't see any bases that are the same. So I just write down my 2 cubed times my 3 squared. I get an a to the 12th and an a to the first, which would give me a to the 13th and a b to the 21st. And that is simplified. There are no other bases that are the same, so I can't simplify any other ones. I can, however, evaluate. So I can do 2 cubed. 2 cubed is 8. And I can do 3 squared. 3 squared is 9. So I'm multiplying 2 cubed times 3 squared, which is 8 times 9, and that would give me 72, a to the 13th, b to the 21st. So I could write it like that as well. Let's try the next. We have an x over y to the negative 4th, all cubed. So to take care of the parentheses, we basically just distribute the cube through the parentheses. So that would give us x cubed, and then this y to the negative 4th, you multiply it times a 3. Negative 4 times 3 is negative 12. And now you're never allowed to have a negative exponent. So we take whatever has a negative exponent and you put it on the other side of the fraction. That is what the law of negative exponents tells you to do. To get rid of a negative exponent, you put it on the other side. You do the reciprocal of only that negative exponent. So that would give us an x cubed because the x does not have a negative exponent, so it stays x cubed on top, times y to the positive 12th. And I could put it over 1, but I don't need the over 1. That's the same thing as x cubed y to the 12th. So the next problem, we see once again parentheses, so we take care of those parentheses by distributing. So we're going to get an x to the 4th, y to the negative 3rd on top, over, when we distribute the 2 through the parentheses, we get an x squared, and a y to the 6th, or y to the 3rd to the 2nd is y to the 3 times 2, which is y to the 6th, because you just multiply the exponents. Now we have a couple of things we have to take care of. We have a negative exponent that we got to take care of, so we put that on the other side. And then, of course, we have x's on the top and the bottom, which we'll get to after we flip the y. So we got an x to the 4th on the top, no more y because it went down to the bottom. We have an x squared on the bottom. We have a y to the 6 on the bottom. And now we have a y to the positive 3rd on the bottom because we got rid of it on the top because it was a negative exponent. So now we have to take care of the x to the 4th over the x squared. So what that tells us, if we have x to the 4th, means we have 4 x's that we're multiplying on the top, 2 x's on the bottom. So I'm going to cancel out these 2 x's on the bottom, but I have to cancel out 2 of these 4, which will leave me with 2 because 4 minus 2 is 2. And then I have to add the 6 plus 3 because I have the exponents here multiplied with the same base, so you add the exponents. So I have an x squared left on top, and I have a y to the 9th left on the bottom, and that's as far as I can go. And the last example here, we are multiplying two fractions, but once again, we have parentheses, so I take care of that parentheses first, basically by distributing. So I get a 2y to the 9th over a 3 squared, x to the 8th, because 4 times 2 is 8, and y to the 4th, because 2 times 2 is 4. On the other side, I just leave it as a 6x to the 7th over x squared y to the 4th. Now, when we are multiplying fractions, we just multiply straight across. So it's kind of like just making this one big long fraction, and I multiply straight across. So I have a 2 times 6. I can actually multiply 2 times 6 because there's no exponents on that. So 2 times 6 is 12. I have a y to the 9th and an x to the 7th. I can't change those exponents, so I just write them alphabetically, x to the 7th, y to the 9th. Over, now I do the same thing here. I have a 3 squared. Well, a 3 squared is 9. I don't have any other numbers, so I'm just going to write it as a 9. I have an x to the 8th and an x squared. So I could take those two and add the exponents to get x to the 10th. And then I have a y to the 4th and a y to the 4th. So I can add those exponents to get y to the 8th. And now I have an x to the 7th over an x to the 10th, meaning that I'm going to have 10 x's multiplied on the bottom and 7 on the top. So I can cancel out 7 of these on the top with 7 of these on the bottom. That would leave me with 3. And then I could cancel out all 8 of these with 8 of those, and that would leave me with just 1. And I also have to reduce 12 divided by 9. 3 goes into 12 4 times. 3 goes into 9 3 times. So my answer is 4y over 3x cubed. And that is all I can do.